questions later. Okay, I'll keep refreshing this to make sure everyone has submitted. Okay, so welcome to MUD 200. Again, we're talking about sustainability, what they call this, disaster risk management, heritage preservation, and urban infrastructure. I added another item here, governance and financing, but I think that kind of fits to all of these four. Like whenever you talk about infrastructure, there's always government and financing over there. I think I also want to switch infrastructure with sustainability. Because sustainability is really the overarching sort of theme or goal. Sustainability of like cities and urban areas today, issues in sustainability. We'll just call it sustainability, infrastructure, disaster risk management, and heritage conservation. Okay. So we'll be looking at terms relating to sustainability, infrastructure, disaster risk management, heritage conservation, but our output will be policies, maps, and analyses. So you can really apply what you learn. And we don't stop just at the terms or theories, but also actually trying to make some kind of workable sort of proposal. And we're starting out with a book recommended by the previous chair, architect Neil Manharis, now working outside of school. I think he works in NEDA now. So he recommended this book to me, and now I'm recommending to you. And sort of to help you out, you don't have to read the book. I'll just summarize it for you. So the book is over here. Let me just show you guys systems thinking. And this is something I'll put up in our Google Drive. Oh, Thinking in Systems is the name of the book. Oops, where is that? PowerPoint, here we go. So this is the book. I'll upload it into our Google Drive in a few minutes, and then you can peruse it later. Okay, back to the presentation. So the whole book talks about systems theory, the idea that everything or most sort of practices and professions create or are part of a cohesive system. So what do you call this? In urban design, it's not just architects, engineers, and environmental planners who create or are part of the built environment sort of system, but also includes social workers, NGOs, and people in the government, and those who are non-professionals or lay people as well. And we all contribute to the development of our cities, barangays, and in a larger, broader aspect, the whole nation. So system theory basically says, looks at an interdisciplinary study of systems. And the idea being that a city is not just the buildings, the streets, the utilities, but all of those different elements working together. So this book kind of tells us like how systems work in sort of just a very friendly beginner level. But in summary, whenever you, for example, adjust or change a system, it not only changes the thing you're adjusting, but it might change something that's completely like on the other side, or like a whole different sorry, a whole different system might be affected by a smaller system. So the example here is, for example, a rainfall or a water in a reservoir. So the water from the reservoir, if you see here on the image, comes from rainfall. So these are natural reservoirs. And then water is reduced through evaporation or discharge, or kanang we use the water, or like we take the water from the reservoir. And then in a sort of a systems analysis, you're looking at the inflow, meaning the rainfall and river inflow, and the outflows, the evaporation, or when we drink the water from the reservoir. So this kind of idea that everything has inflows and outflows is very important to note because, for example, we apply it in housing. So we have incoming housing that has been sort of approved by the government. We have the existing housing structures, those that are already like built, and then the outflow are those that are demolished or those that need what they call this to be repaired or maintained. So the idea is that things are always changing. It's not just the water in a reservoir, the number of housing units, basically anything you can think of would fall into this sort of a system structure. And it's always in a state of either increasing or decreasing. Our goal as urban designers is to identify if it's actually increasing or decreasing, and whether we want it to increase or decrease it or maintain it at the current level. So the book goes further to talk about another item called stock. So it's basically anything that you can measure or count. So for example, earlier we talked about water in a reservoir. The stock is the water. The inflow is the coming in of water, regardless of where the source is, and then the outflow is like where the source is like sort of being taken out from. So we also talk about feedback loops. So when a stock is changed or either increases or decreases, that is what we call a feedback loop. It triggers a process to increase or decrease or maintain a stock level. So stock can be anything: housing, water, let's say even something more abstract like the level of use in a street. Like for example, traffic flow. The stock would be the road or the thoroughfare. The inflow would be the cars coming in from the residential areas and they're going to like wherever they need to go, like working areas, like commercial areas, etc. Okay, so now this is a bit abstract, but for just like try to wrap your mind around it. For example, I'm the only one giving examples here, so it's already been 30 minutes. Why don't you guys tell me an example of a stock or an item or a sort of built environment feature that you're interested in studying? So please use the chat box here and give me an example of a stock. You can type it here, or actually, I think I have a, let's see. Let's make a Jamboard. Let's create a new one. MUD 200 Jamboard. So it's more interactive. I'll give you guys this link. Copy link. So please jump onto the Jamboard and then you can create, let's see, let's just do a sticky note. So for me, my example would be housing. Stock equals housing. And the inflow is, oops, I made it into one thing. Can I? Inflows is housing approvals. Stock is housing. Outflow is housing demolished, or being demolished. Something like that. And you can make it bigger or smaller. I'll put your name in the beginning as well. I'll put my name here. Where's everything? You can put. Oh, no, that's the only thing I can do. So yeah, jump onto Jamboard so we can see your responses in a sort of better way than just a chat box. And this will go to your class participation. If you're on your phone, I guess you can't join. Try to open your laptops. And then, what's this? Oh, okay, that's for another thing. Hello, guys, come on. Or are you all on your phones? Because I only see one person, two persons coming in. So what you do is you click here, sticky note, and it allows us for like a more sort of interactive session. This is something I'm trying this sem, especially with a smaller group. It's really effective to make the class more lively. Sige. Should be able to just jump in. If you're having problems, let me know. I see people joining, but nothing's being posted. Yes, go ahead.
Excuse me, sir. Dili na ko makita ang kuan kining sticky notes or para maka-input.
Mo ba?
Wala pa ning
Sige.
icons.
Let me share as. Oh, you're only sorry. You're not editors. Sorry about that. There we go.
Okay.
Try this. Try that link.
Okay.
Okay, nakita na.
Okay.
Okay. Can I change the settings up here? I don't think I can. So try clicking on the other link. Here, the second link, and it should give you editor sort of power, so you can write, you can draw, whatever. Okay, does everyone have access to the sticky note? Yes, go ahead, Benson.
Hi sir, kanang I'm not so experienced pa kayo sir, so later na ko mo answer sir.
Yeah. You could answer na lang with your microphone.
No, like di kay ko experience pa kayo sir. Like I'm not an architect po mat that good that I haven't.
Okay, you're not. No, this. Okay, very good. What is your background?
Architecture student ko sir, pero I'm not an architect pa mismo. I haven't been.
Okay, okay. Yeah, the stock can be anything. It doesn't have to be housing. It could be something like I mentioned earlier, reservoir, water. You can think about food, like for example, restaurants. The stock is the food in the restaurant. The inflow is the raw materials, and the outflow is like when the food is being consumed. So something like that.
Okay sir, thank you.
Try. Doesn't have to be architecture related or building related. It can be anything. That's why we're starting with something abstract lang sa. So over here, the example is on this slide, we're talking about balancing loops, a loop that sort of stabilizes the inflow and outflow, meaning it it maintains the amount of stock in whatever system you're in. So over here is on the left side of the screen, our stock is energy available for work. You meaning like a person, an actual person. The inflow is the stored energy in the body, and then the outflow is energy expenditure. So example, you're working in an office. How do you sort of balance that loop? Because if you just sort of work in an office, magutom ka, you get tired. So how do you bring up your energy levels for work? You drink some coffee, or whatever, you get some snacks, and that increases your energy available for work. So you always have energy. But at the same time, while you're working, you're constantly expending energy. So this is what the book mentions, or Meadows, the author, mentions as a balancing loop. So if you think about energy available for work, you're always spending energy, but how do you keep on working throughout the day? You drink coffee. So something like that. You can write it. You can try lang to write something down. If you're not familiar with architecture, okay, Rajat. Let's see. Let me go back to the Jamboard, see if we have anything new here. We got one. I'll just make it bigger. Stock is the college student. The inflow are high school graduates, and the outflow are college graduates. So yes, that is correct. Sige. We have one from Kathy. I'll change my color so that it doesn't go on. Edit.
I'm not sure on that, sir. I just tried.
Try lang, yeah. Okay, first meeting pa bitaon. You will get the point as long as you participate. Participate, just try lang yun. That's all I'm asking. Okay, now we got something here. Sige. Inflow, safety regulations. The stock is public health, and the outflow is the protocols that's being implemented. Okay, that can also work. Yes. Okay, Benson. So your stock is plants, the inflow is rainwater, and the outflow is produce. Oh, I'm seeing some patterns here. We'll address it once we have everyone. Okay. I'm just making space for Joyce here. So we have, I think, 10, 11 students. So maybe we'll get 1, 2, 3, 4, 5. Try to get 10 more, or maybe if we get 8, then we'll proceed. So we have Joyce here. The stock is inflow. Blah, blah. Asa ang stock ani? The stock is the metals. Inflow is mining of metals. Outflow is technology. You're missing the stock. So again, going back to example here. So the stock, whatever it is, will require raw materials, or like an inflow and then an outflow. So the example of what they call here, Kathy over here, the stock is public health. And then what is the inflow of getting public health? Do you mean public health like in general, like that everyone is healthy? Or do you mean like the documents that support public health? Because your inflow is safety regulations.
The documents, sir.
Okay, the documents. So I guess the outflow there is kanang protocols, but I think more specifically would be an outflow would sort of decrease the number of those stock. So how do you decrease the number of sort of public health documents? For me, I think protocols is an output, not an outflow. What I think about how health documents would be used up. I think documents could be a bit too abstract. An example, kaya di ba mahurot ang documents, you just keep on compiling it. Like for me, I would think about physical documents na mawa or outdated. I think that would be a better outflow. And then that's a good first attempt though. Okay, and then Benson, we're talking about the stock is plants. So your outflow would be kanang the plants dying, something that would kill the plants, and not the thing that the plants produces. Again, sort of, this is good. We're really defining what outflow is. Outflow reduces the stock. So if you create like fruits and vegetables, it doesn't kill the plants, bitaw. Something like that, plants dying, yeah. Okay.
Thank you, sir.
All right. No, so we're all getting it a bit out. So there is an item. The item requires raw materials. Eventually, the item will degrade or kanang die. So not everything is permanent. If we go to the built environment, even the buildings, even if they last like 50 years, sometimes even 100 years, they're still eventually will decay or need maintenance. Otherwise, they'll just like get destroyed. Okay, we got some other samples here. Okay, everyone's coming in. Okay, I'll go with Paul first here. So his stock is business knowledge. And then the inflow is social media business information, basically knowledge, like where you get knowledge, books, information, etc. The outflow is quite a bit questionable. So when you apply your business knowledge, does that mean you have less knowledge? So what is something that would reduce business knowledge? So that's a bit abstract, but you can try. What would be kanang, I think an outflow would be how someone would lose knowledge is they stop practicing business or something like that. So muna siya, outflow is something that decreases the amount of stock that you have. So I don't think you lose knowledge if you apply your knowledge. So that doesn't sort of connect as an outflow. So that's a good start. Okay, here, the stock for Joyce here is demand for technological products. So as long as we have raw materials to create the products, then you should be able to, what do you call this? Yeah, create the products. And then the outflow is, what do you call this? A bit off as well. So the outflow is something that decreases the technological products. So for example, if you create chips, you create new materials, it doesn't really, what do you call this? In a way, I guess, if you really squint at it, if you increase the supply of technological products, the demand for it would go down. So I guess technically it works. Okay. We have here Bus Mayor. The stock is the ecosystem, goods and services. The inflow is urban trees, and the outflow is illegal cutting of trees. So that's correct. That's exactly what the I'm trying to get at. And then over here, will I name? Please include your name. Kaning stock is tree. The inflow is seed. The outflow is not fruit, but illegal cutting or the cutting down of the tree. So your outflow takes away your stock. But I think we all sort of understand that now. So 1, 2, 3, 4, 5, 6, 7. So kanilang 7 ang makuha class standing for today. Ha? Okay. Anyway, moving on. Okay, so now we understand na whatever thing that you have, whether it be a energy, whether it be a building, fruits, trees, materials, they will always be used up. And we need to find some way to replenish the raw materials. Otherwise, we will eventually run out of that stock. So for an example over here, just like how zoo animals give us a snapshot, but not the full picture of wildlife. For example, you go to a zoo, you see some animals. It's not the actual sort of jungle, but it represents a simplified model of the world. So some items here that we can observe when we simplify things, when you create a diagram to represent whatever we need to represent, we can observe what is a renewable stock and a non-renewable stock. For example, we go here to your, what do you call this, Jamboard. The trees and plants are renewable because you can plant new seeds and then you can wait for them to grow. But key thing here is you have to wait for the new trees to reach maturity. But it's still a replenishing or kanang a stock that you can replant, regrow, etc. And a stock that doesn't regrow over here is by Joyce, kanang mining of metals and raw materials. You can't grow metals. So once you use up all the silicone, etc., then it's gone. Maybe there's a new process nowadays that can regrow metals. I'm not aware of that. Okay, so we're getting somewhere. Nice. And then finally, let me increase my slides over here. You can also, by creating this diagram, you can draw it, or we just wrote it down. You can see how different variables affect different systems. So the example of a high school, graduating students and incoming high school students, those inflow and outflows are also impacted by their own different sort of kanang variables. So high school graduates depends on the number of enrollees for high school, depends on like the how many kanang finish high school, the education system in high school, the tuition fees, etc. And then the outflow, the post-grads or those who finish college, other factors that dictate that will be how they learn in college, the system in college, and it's different from the system in high school. So just getting into this thinking that everything we do, everything that we have is controlled by different things and have different sort of variables. And most importantly, some stocks are renewable and some stocks are not renewable. So this will play into our discussion of sustainability in a bit. And then Meadows, the author of this book, warns us that it's really impossible to fully understand dynamic, self-organizing, non-linear systems, much less predict or control them. So now we're in. I'm bringing you back to urban planning and urban design. As much as we want to create things and have people use them the way we want them, it's really impossible to, what do you call this, instruct people to use sidewalks the way we want them to use sidewalks. A clear example here would be our roadways. We can teach people how to drive. We have a system to create driver's license. But at the end of the day, we can't predict when a vehicular accident might occur. We can't predict or control how the drivers behaved while they're driving. So the system, or the, what they call this, the diagrams are just there to help us sort of figure out what's happening. But to fully understand it, fully control it, is basically impossible. What we can do as urban designers and urban planners is just to manage it in a way na we can maybe improve what's going on, or avoid accidents, or mitigate accidents on kanang bad effects or negative impacts that we want to not experience as often. So it's basically like trying to control the weather. And in this book, which I will share with you in a few minutes, I just want to finish my presentation. If you just want to skip to the end, you can. So over here at the end, there's a nice appendix here describing each of the topics. So let's see here. Let's say appendices. Okay. So have your glossary of terms, and then much more important is the definition of a system. So a system, or like a system, is more than the sum of its parts. Many of its interconnections in systems operate through the flow of information. The least obvious part of the system, its function or purpose, is often the most crucial determinant of a system's behavior, etc., etc. I just gave you a quick overview because we're a bit behind. We're 1 week behind. But this is basically the kind of thinking that I want you to apply when we talk about urban design and urban design issues later on. We can see the different sort of parts of, for example, an urban design issue like sustainability. Like, we want things to be more green, we want to have more vegetation, more plants. But each of our local communities, each of our barangays have different amounts of existing vegetation, different attitudes towards vegetation. Like, for example, in the rural areas, they'd be happy to cut down a lot of trees because they still have a lot of trees. In urban areas, it might be different. They want to protect trees because there's not a lot. So it really varies from location. And at the same time, each system behaves differently in different locations. And then over here, just a quick summary of stock flows and dynamic equilibrium. So a stock is the memory of the history of changing flows within the system. So this is a bit vague, but if you think about it, I'm really trying to push this. If we think about the number of trees currently existing in the Philippines, if we get a report from DENR that there is X amount of trees currently, what Meadows is saying here that it's a memory is because that record is only good at the time that it was taken. We can never know the exact amount of trees at this exact time because it's constantly changing. We never know the number of cars at the road at this exact time unless we have access to the video cams, and even then it's constantly changing. Anyway, the key point here is that we can do our best to control, to get all the data, but in a system that's constantly changing, for example, a city, a barangay, a town, wherever people live, it's really impossible to have a 1:1 perfect solution. So this is just giving you guys a understanding that we can never get the perfect plan. There's no such thing as the perfect city because it's constantly changing and it's impossible to pinpoint how to solve each problem every time. So you can only solve some of the problems in some capacity every time. Maybe sometimes you can get it right perfectly, but most of the time you'll probably just get maybe like 80% or 70% correct. And that's already very good. Like I think 50% or even less is what's currently happening in the Philippines. And then over here, just a critique of how to read the book. It has a positive outlook of problem solving. It challenges readers to change their perspective, as we have done like right now, like to think about stock inflow and outflow, although it's a very summarized version. And then some of the descriptions are a bit too vague sometimes. It's a bit meandering. And we could use better examples for urban planning and urban design, and might be a bit too biased in some of its examples. Okay, so we'll do a sort of residential project demonstration of systems thinking, and then also do a commercial project demonstration. For example, let me just open up my board over here. So thank you for your participating in the Jamboard. And so you got 1, 2, 3, 4, 5, 6, 7, 8 people. I think the only people who didn't join are those who are absent. But since we're talking about urban design, let's look at some residential examples of this sort of systems thinking at work. Okay. Let me set it up here. Okay, I like to use Photoshop as my blackboard. File, new. Let's get a big DPI so we'll be zooming in and zooming out. Oh, image canvas. Pixels. Okay, so let's do a residential example, because this is urban design. So bringing it back to the topic of urban design. So function B. Okay. Let's use a blackboard, right? In case it's mata, and I'll use a white brush. Okay. So residential example. So let's say again, my example earlier was the house. So let's say you have a house. House. Rugby architect. Anyway, we have a house. So this is our stock. So what are the different inflows that will create this house? So let's get a bit technical. So to create a house, you need raw materials. What are the raw materials for the house? You have your concrete, you have your timber, steel. So concrete, timber, steel. This is your inflow. And then your outflow is what causes the house to be destroyed. So several things. It could be, for our class, since we're talking about disaster mitigation, you have typhoon, your house gets blown away, earthquake, and other natural disasters. And then you also have fire, etc., etc. Now, can we predict when the next typhoon will happen? No, I don't think so. We can like estimate. Earthquake, we have like a warning system, but nobody can really say mag earthquake, ugma, mag natural disaster, ugma, etc. But we can sort of mitigate the effects of the typhoon, earthquake, natural disasters by improving the how the building is constructed. So we need good quality concrete, good quality timber, good quality steel. So this is just a house example. Now, like let's say we're going to apply this more specifically to urban design. So for me, urban design is really the public space. So let's say you have a sidewalk, and I'll just do a section. You have a building over here, sidewalk, road, sidewalk, then building again. Okay. So in just like a street, let's just call this a street. just to show you how complex our sort of urban design is. In the street, you have several stocks. You have the people on the street. You have the buildings. You have the road. And then you have the, I'll just call this sidewalk SW. Okay. Our example would be a street in, let's say, Talamban, because I'm in Talamban. And then where the book says that systems are complex, if you look at any street, it's already very complex because you have different stocks here. Again, the building, the people, the street, the road, the sidewalks. So that's already 4 stocks, and they have each their own inflows and outflows. They have each different activities and different objectives that in any particular street. So what would cause people to walk through this street or use this street? Maybe they need this street to get to their work or to their house. And then, of course, I forgot another thing, the cars. So just how complex urban design is, like in any given project, you have several different stocks that are working together, have different objectives. So it becomes very challenging to manage or like create a design that will address all their problems. That's why for our first session, we'll just like thinking about the different elements inside this our cities basically. Okay, a commercial example would be, I guess for the purposes of urban design, we can talk about a commercial district in any city. For example, in Cebu, we have the, I'll just bring up a map here so it's more interactive. Ayala Business Park. Let's get an image like this. Okay, something like this. Okay, and I'll put it in here. Refresh. Okay, where did it go? I think it went to my desktop or something. Yeah, it did go to my desktop. Desktop. Okay. So this is no longer a street, but a whole district, a whole area. So you have, what do you call this? You have several buildings, you have several streets, several roads, several sidewalks. And the thing that will sort of make this even more sort of complicated is that all of these different structures, spaces, all have different owners. So for example, the Ayala building over here, this is one owner. I think this is still Ayala. This is another commercial building. That's a different owner. This is another commercial building, different owner, different owner. And then as urban designers, where are we working in? We're working on the public space here. Let me change the color of my brush. This is where our proposals and designs will take shape in the space between the buildings. So how do we get our proposals approved or sort of basically off the ground? Is we have to satisfy the client over here, it's client 4, client 3, 2, and 1, so that they will be happy with the street and like we'll use it at least as well as we can plan it, and then it will be a win-win situation for everyone. So again, to reiterate, this idea of systems thinking can be applied to any stock, and then we take that one stock and study its inflows and outflows, and then we look at the street level. So for example, like any street in Cebu or in the Philippines, and then we realize that each street or each location has several different stocks existing together. And like as urban designers, we need to identify them, sort of figure out how they behave, so we can create designs that will fit their behavior and hopefully improve the living quality or the quality of life in any street any house, or more practically, any district or urban area. So far, are you guys with me? Basically, everything I said, you can summarize it into urban design is very complicated. Urban design is complex. And then the problem is that during sort of my time, like early 2000s, most urban designers and planners, people in the built environment, tend to oversimplify issues and problems, and what they come up with are very half-baked, not well-studied solutions. And I think that's still happening today. So in our class, we'll try to dig deeper, go into sort of the different inflows and outflows of each issue. So our first issue will be sustainability. And then let me just prepare some slides. I think I have some slides on that already. But for now, let me just check the promissory notes if nakasend na ba tanan. I'll stop sharing here and I'll separate this recording into another video. Para you can like